So welcome to Scale Hydroplane Construction. My name is Mike McKnight. I am the owner of ThunderboltGraphics.com. I'm one of the guys that you guys call to get the nice pretty graphics for your boats. I'm also the owner of a company called ProLine Media, which is my main line of business where I do audio, video production, and motion graphics, which allows me to be able to bring these really cool videos to you. Well, let's get to the reason why I'm actually bringing you these videos. I get a lot of questions, as I am the NAMBA scale chairman. I get a lot of questions about, hey, how do I make this for my boat? Or what do I do about this? And one of those questions has been, what do I do about a turbine tube? If you're making a boat from, say, the early 1980s or around 1980, starting with like the 80 pay and pack, up through boats even into the mid and late 90s, a lot of them, especially ones like mine, I run an 89 Circus, have a long turbine tube on there, and that's been a constant problem. When I first got into boating, I asked the guy that I got my first scale hull from, I said, what do I do about a turbine tube? What did he do? He sent me a big aluminum tube about this big that was as heavy as a boat anchor. It was crazy. I'm like, okay, great. I'm really going to put that on my boat? That thing's heavy. So now we're going to teach you how to make one that is not only durable, but nice and light, and also will stand up to a little bit of punishment as well. And we're going to teach you to make it out of fiberglass or carbon fiber. Okay, so first, let's talk about the materials that we're going to be making this out of. You can do it out of one of three materials or even a combination of a couple of these materials. First and foremost, we're going to be dealing with something called E-glass or S-glass, and this is kind of what it looks like. E-glass is your basic fiberglass cloth. E-glass, you could say it's for economical. It's probably the lowest cost fabric you can get out there. It has good tensile strength when you add some resin to it. Then you move on to something called S-glass. S-glass is a little bit stronger depending on which manufacturer you get it from. It could be anywhere from, say, 30 to maybe 40% stronger than what E-glass is. And then we'll move up to something called carbon fiber, which is this. And it comes in a couple of weaves, as they call it. There is a crosshatch pattern, which is basically a 90-degree weave like this, or it comes in at what they call a twill weave pattern, which is what we're going to be using. And the reason why we use the twill weave is this. If you've ever watched, say, Formula One car racing, any type of auto or boat racing, a lot of their parts are made out of twill weave. In fact, the military uses twill weave on a lot of things for like helicopter turbine nacelles. Almost any plastic part you see on any type of military equipment made out of twill weave, carbon fiber, and sometimes Kevlar. We're not going to deal with Kevlar because that's a little too heavy for what we want to do. Okay, so now let's talk about the tools and other materials that we're going to need in order to make this turbine tube. First and foremost, I highly recommend getting one of these. I know it looks like a pizza cutter, right? It is in fact a rotary cutter. And the reason I recommend one of these, I got turned on to these by a company called Aerospace Composites over in the Livermore area, which is between here in the Bay Area in Northern California. These are absolutely awesome. If you're going to be a scale boater and you're going to be working with fiberglass on a consistent basis, I highly recommend getting one of these. In fact, they come in a couple of different sizes. You can get the 60 millimeter or you can get the 45 millimeter. I actually just bought a new pair of both of them because the old ones I had were so gunked up and used, because I've been using them for over 10 years. So I bought some new ones. They do have interchangeable blades. You can get them anywhere from Walmart to maybe probably find them a little cheaper on Amazon, but they're all over the place. You're going to need a regular pair of scissors. You're also going to need a tape measure or some kind of yardstick. You're also going to need some sort of plastic spreader or squeegee, and I'll explain why you want to use plastic here in just a little bit rather than metal or wood. You're also going to need some acid brushes. If you're going to be a scale boater and working with fiberglass, buy these in bulk. It's a whole lot cheaper. Seriously, buy these by the gross, 144 at a time. It'll last you forever and it'll be a whole lot cheaper in the long run. You're also going to need some mixing cups and some stirring sticks. I just use popsicle sticks. I get these by the bulk of the box at Walmart. You are also going to need some latex gloves because you don't ever want to work with epoxy resin without latex gloves. You're also going to want your epoxy resin. And me personally, I use West Systems epoxy. It's a two-part epoxy system. You have a resin and a hardener. For this evolution, we're going to be using the 105 resin with the 205 hardener. The 205 hardener is the fast hardener. We don't necessarily need a lot of working time for this operation. If you want to work on a part that's going to require a little bit more working time, then you go with the slower hardener like the 207, or if you're getting into other projects that require special finish, they've got other hardeners as well. But it's a really good system. It's basically a 4-to-1 system. You're going to be using 4 parts resin to 1 part hardener. And we'll get into more of that here in just a second. Okay, and one other thing that you're going to want to pick up, and you're going to need it for this particular evolution. In fact, you're going to need it for doing a lot of things. And that is, let me get rid of this, here's some transfer tape, is some Mylar. This, I picked this up at a place here, or near here, called Tap Plastics. They have all kinds of cool fiberglass stuff and plastic stuff. They've got locations all over Northern California, I believe all over the West Coast, all the way up to Washington. You can pick this up online too. You can even get it at hobby stores like Hobby Lobby or Michael's, any of the big chain stores. They should have some of this stuff too. They usually sell it by the foot or by the yard. I usually pick up about 5 or 6 yards at a time because I do a lot of fabricating of parts for boats. In fact, you know what? Let's start with the Mylar, and I'll show you how the rotary cutter works, because let's get some of this stuff out of the way, get some of our tools out of the way. We're actually going to need that rotary cutter to start with. Let's get this stuff out of the way. In fact, we probably won't even use the scissors during this evolution, but you never know. All right, so basically what we're going to do with this Mylar is we're going to use this as a laminate, basically. Now, this technique that I'm going to show you too can be used for any scale boat, whether it's 8 scale nitro, 8 scale FE, 10 scale, also 6 scale gas. A lot of guys are doing turbine boats for 6 scale gas as well. All right. So we're going to be making one for 1/8 scale, which means I'm going to need a piece of material here shortly, which I've actually already got cut, but we'll cut another one here a little bit too. Let's see. For that, let's see, that piece was 9 by, or about 10 by about 18. So we're going to need some overlap. Let's cut a nice size piece of Mylar, that's a boat. Anyway. Let's see how easy that cuts. It's like a pizza cutter. It's so awesome. I'm telling you, once you buy one of these, you will you'll never use scissors for a lot of stuff ever again. Those of you that are advanced users of fiberglass and carbon fiber, you know what a pain in the butt it is to cut carbon fiber with scissors. Carbon fiber likes to unravel on you a lot. It's kind of a hassle that way. Okay, so what we'll do is we'll take this piece and we'll cut it exactly in half. We'll have 2 exact replicas of one another. And let's see, we're looking at, let's cut this right down the middle, about right here. All right, there we go. Now, we have got our 2 sandwich pieces of Mylar. All right, we'll lay that piece of Mylar out right there. All right, and as I said earlier, I've already got a piece of carbon fiber basically already cut, because we're going to make this out of twill weave. And we'll straighten this up a bit because we're going to shorten this piece up just a little bit. Let's see. Typically for a 1/8 scale, the average diameter of your turbine tube is probably going to be somewhere between 2.5 and 3 inches, probably no more than 3 inches max. So we only need a piece. I'm going to make this one about 16 inches long. Yeah, 16 inches long. See how easy that cuts? And then you get a nice straight edge on there as well, which if you try to do that with scissors, I'm telling you, you will be so ridiculously frustrated, because see how it already likes to fray and go crazy on you? All right, so we're going to move our Mylar back over here in place, and we're going to start wetting out our material here in just a sec. Oh, one other thing that you're going to need, and I've neglected to mention this, but I'll mention it now, and this may not even cost you a dime. You can actually go to a local landscape guy and see if they've got some scraps of this laying around. Go ask them and see if they've got a piece of ABS, which is what this is, or PVC pipe I don't know, roughly a couple 3 inches in diameter, because you're going to use this as a former. More than likely, they got some scraps laying around. They'd be all too happy to give you a piece that's, you know, a couple feet long. I use these. I also use cardboard tubes, which I have a ton of them in the graphic shop. In fact, I've already got one turbine tube laid up right there. I'm actually making one for someone right now. So anyway, you're going to need that for a former, and you'll see why in just a second. All right, so let's get started with wetting out our material. First things first, we need to get some gloves, because trust me when I tell you that you're working with any type of epoxy or fiberglass resin or polyester resin, you really, really don't want this stuff getting in contact with your skin. It is not really good for you, and it's a monumental pain in the butt to get off too. We're going to be working with some fairly small amounts, so I'm not going to worry about any eye protection or respirator issues today. And let's see, where'd my mixing cups go? All right, so we found our long lost mixing cups here, and we will start out with a couple of pumps of each. In fact, one of the reasons why I'm doing this here at the office is that, one, it's better lit, and it's easier for me to control the temperature here too. Here in Northern California, and some of you are probably going to laugh at this because I know you're in parts of the country where it's extremely cold right now, but for California, when we get into the 30s, it's considered ridiculously cold. Of course, I'm sitting here wearing shorts, but that's okay. A little bit extra there. Okay, so basically we've done 3 pumps of each, which should give us enough resin to wet this whole thing out. So you're going to stir this up really nice with your mixing sticks or popsicle sticks, and we'll get rid of that, and we'll grab an acid brush. Like I say, these you can get Home Depot, Lowe's, wherever, but like I say, I buy them online in bulk, and it's a whole lot cheaper. Okay, now we're going to start wetting this out. In fact, I'm going to lay this right down the middle, because we're going to be working from the middle out on this, and I'll show you why here in just a minute. But you're going to want to lay out this resin, sit it back here on the mylar, and we're going to start working it back and forth, wetting out the resin, or wetting out the cloth, the carbon fiber. And it's a lot easier to keep it more temperature controlled in here, because this morning when I started coming over here to film this video, it was about 33 degrees here in Northern California. I know some of you are laughing, going, whatever, dude. Well, that's, for California, that's cold. And for working with fiberglass resin, that's extremely cold. You really don't want to work with this stuff in temperatures below 60 to 70 degrees. In fact, 70 is usually the dividing line there. Okay, so we're going to bring this out as far as we can out to the edges before we might need just a little bit more resin. I try to be as economical as I can with this, but when you're making one-off parts like this, you're going to have some waste. You're going to use a lot more resin than you probably would if you were vacuum bagging, or you know, if you're one of these guys that's super rich, that's able to afford an extruder, which is how carbon fiber and glass tubing is normally made. But if you've got one of those, then you're going to be making hundreds or thousands of these parts, not just one or two. But at least with this technique, you'll be able to make one whenever you need for whatever build you're doing. Plus, with this technique too, you can make a lot of other parts that you're going to need for your boat eventually. Now, when you're wetting this out, you want to take this resin out as far as you can, maybe within, say, ½ an inch of the edge of the material that you're wetting out, carbon fiber in this case. Like I say, you can do this with regular weave carbon fiber. I just, like I say, I just prefer the twill weave because it's a little bit stronger. And you can, by the way, the weight of the fabric, when you go to buy this stuff, you're going to see it in different weights, anywhere from 3/4 of an ounce, not this, but regular fiberglass. You'll see it in 3/4 of an ounce all the way up to, I think I've seen as high as 10 or 11 ounce. But we're using the 5.7 ounce. That's the one that you need to use so that you can get away with using just one layer of glass. We're going to do one more pump of resin just for giggles. I want to make sure I have enough resin on there because we're going to be squishing this out to the edges here in just a sec. A little chilly in the office when we came in this morning, and it's got the resin a little thick, but that's okay. It's warming up quickly in here. I just want to make sure that we get this resin all the way through the fiber. I know some of you guys are going, oh, good God, he's wasting a ton of resin. Well, you'll see why once we get this all wet out. Yeah, you're going to have some waste, but like I say, one-off parts, you're going to have that. There's just no way around it, really. Some of you guys that have vacuum bagging systems probably could try this. I've never tried it with a vacuum bag system. Most of my parts that I've done vacuum bagging have all been like wing halves and all kinds of other stuff. In fact, I've got another subsequent video that I'm planning where I'm going to be making a mold for a cowl. And I'll show you some hopefully show you some vacuum bagging techniques with that. I've got to finish out the plug and some other stuff. Okay, so we're pretty well wetted out. And we're going to set this off to the side in case we need a little bit more resin later, which I don't think we will. We'll set these over here. Okay, now we are going to take our other piece of Mylar and we are going to lay it over the top of what we have here now. Now we've got plenty of edge on both sides, or on all sides of this. See how it's already starting to, and we're going to grab our squeegee. Now we're going to start working from the middle out, and we're going to push this resin all through the fabric, making sure everything is nice and wet. Now the reason for this Mylar is several. One, you can peel this off later, and you'll see once we get it formed and peeled off, what a nice finish it will give your part when you're done. Those of you that have ordered Fritz boats or a few other manufacturers, you see this really awesome finish because these guys vacuum bag a lot of their stuff, and it really gives the boats a nice finish. This will make it look almost as nice, if not nicer. Nice and shiny, and hopefully no pinholes. If you've never worked with fiberglass before, you will learn about pinholes, trust me. Pinholes are a gigantic pain in the butt, especially when it comes time to paint. And I, for one, have dealt with pinholes like you would not believe, especially when working with carbon fiber. Because when you start sanding it, if it's not full, the fabric is not fully impregnated with resin, man, are you going to get pinholes. And then you're going to have to put a whole lot more primer on there to fill those pinholes. See how I'm pushing this with the squeegee, and as I'm going along, that's impregnating all the fiber with resin. It's working it all the way through. In fact, we're going to flip this here in just a second, make sure that we've got both sides pretty well covered. Now, for some of you that are advanced in fiberglass, you're probably wondering, why would you go to all of this trouble? Because this is a fair amount of work to make a turbine tube. Well, there might be easier ways, but just for me, I have found this to be an extremely effective way to make a turbine tube over other things like having something out of rolled metal, which I've done rolled metal. In fact, one of my boats, my X-Side, has a rolled stainless steel turbine tube on it, but it's a very short turbine tube. And my friend Alan Terry helped me make that because he used to make stainless steel tanks for outriggers and still had some of that material around. However, this, God forbid, if somebody runs you over or if you get hit and you get a scratch on your turbine tube, or say it even gets destroyed, God forbid. Okay, so we'll flip this over, work out the rest of the air bubbles. This is actually a whole lot easier to repair or replace than a metal turbine tube. Metal, you're never going to get it straight again. It just isn't going to happen. If it gets scratched, the finish is extremely hard to fix. This, and you'll see in the last part of the video, once we get this formed and we go to finish it, because we're going to be covering this in vinyl, believe it or not. And if for some reason it gets scratched, you simply take a hairdryer or a heat gun and you heat up the vinyl and peel it right off and then put a new piece of vinyl on it. Not to mention the fact that, and I've actually done some weight tests on this, more often than not, this method right here, a piece of carbon fiber for a turbine tube, is considerably lighter and stronger than having a metal turbine tube. I'll also show you when we get into the second part of this video on how to make your aft deck cradle for this. And now there's a couple of different ways that you can do it too, because obviously FE is going to be a little bit different. Gas and nitro might be about the same, depending on whether or not you're going to run your tune pipe out through the turbine tube or not. A lot of guys, in fact, I'm going to have to take my gloves off for this. We can take the gloves off now anyway. Okay, normally I would be doing this part of the operation here with some blue painter's tape, but I unfortunately am out of blue painter's tape at the moment, so we're just going to use regular. Actually, you know what we can use? Yeah, I got some other tape here. I got some transfer tape I can use. Okay, so now your piece is all nice and wetted out. You've worked out all your air bubbles. Now here's where that piece of ABS or cardboard comes into play. You're going to take this piece right here. In fact, you know what? Let's get this out of the way over here. We can actually throw that mixing cup away. We don't need that. Now you're actually going to take your piece of ABS and you are going to roll this whole laminated piece onto the ABS or PVC or cardboard or whatever you're using for a former. You're going to roll it on there. There you go. Okay, and then once you get it on there, there's the end of your Mylar right there. Once you get it on there, you grab yourself a piece of tape. I'm actually going to grab my transfer tape, which is a lot less sticky than regular masking tape, because you really don't want to yank on that Mylar too much. You're going to take it, and then you're just going to tape it in place. Okay, now it's all on there. You're going to let this cure for minimum 24 hours. If you can keep it in 70 degrees or above, take it in the house, put it somewhere where it's going to be out of the way. If you set this up on end, like I usually do, make sure you got something underneath it in case you have some resin that leaks out the side of your Mylar right here. So you can just set this aside. In fact, you know what? I'm going to put one more piece of tape on here because this wants to slide. We'll take a piece of regular tape. That's another thing too, especially if you're using the ABS or the PVC. There's not a whole lot of grip on there, so you are going to want to, you know what, I'm just going to take a piece of transfer tape here. Oh, hey, look, we actually get to use the scissors. Cut a piece of that off, and then we'll just put this up here over the top so that if you want to set it on its end, it's not going to slide on you. Okay, so there it is right there. Now you're going to set this aside 24 to 48 hours, and then we'll come back to it and we'll peel the Mylar off. All right, so we went ahead and pulled our turbine tube off of our ABS. Then I'm going to take the Mylar off. Now the outside of this one came off particularly well. However, the inside was a little bit of a pain, as was expected, because unfortunately, since Mylar is plastic, Mylar doesn't like the cold either. And as I mentioned before, it was a pretty darn cold day today. In fact, when I got here this morning, it was a nice 28 degrees, which for California is pretty darn cold. So I'm going to take this back to my garage. And to get Mylar off when it's been a little bit of a pain trying to get it off of there, simply just get a hair dryer or a heat gun. If you've got one of those, let's see, I don't have it here. If you have like a Stanley heat gun like you use for house painting and stuff, for like removing paint on surfaces at home, or whether you use one professionally, even a hair dryer work, it doesn't matter. Just simply heat up your turbine tube as you're pulling the Mylar and it will gently release. Now be gentle with it, and the other thing you got to remember too is that if you got to heat it up to get it off of there, just little blasts of heat at a time. Don't keep it on there constantly and heat your part up to the point where it's going to deform it. Once you get all your Mylar off, then you can simply take your turbine tube, and you're going to do this one of two ways actually. You can, first you got to determine, of course, what size it needs to be. But simply once you've cut that edge, take one of the edges after you get it off of there, put a piece of tape down on there, make a nice straight edge, cut along that edge with either some scissors or a Dremel cutting wheel, and make that edge nice and straight. Then once you've got that edge straight, you're going to want to measure the opening, the aperture of your turbine tube. Say, now as I mentioned before, most turbine tubes are going to be 2.5 to 3 inches. Actually, that's not quite right. I kind of misspoke there, because on my particular boat, it's going to be about 3.5 inches, because the back of my cowl is a little bit large. So once you get it measured to the area that you want it, take a clamp or maybe some alligator clips or something like that, clip it in place once you've got it measured. Take the other end, measure it, clip it in place. Then you're going to see some overlap where your seam is. You're going to see some overlap where your excess is going to be. Clip it on each side, okay? Then you're going to cut right down the center of where those clamps go. Now you're going to have a nice straight edge, or hopefully a straight edge, at least a matching edge anyway, where you're going to be able to butt those two up against each other. If you want, and you're not happy with butting them up together, each other like that, you can do simply a little bit of an overlap, maybe about 1/8 of an inch overlap. Okay, and then all you're going to do is you're going to tack those. In place with some thin CA, and then you're going to come back and we're going to lay some resin over that seam. And we'll show you how to do that in just a sec. All right. As soon as I get back from the garage, we'll go ahead and lay some resin in there. Okay, and what we're going to do that is we are going to cut a piece of e-glass. I just happen to have, of course, this roll of 3-ounce e-glass here. We're going to take this and we're going to cut a piece of fiberglass tape, basically, roughly 1 inch wide or so, and that is what's going to seal up your seam. So we will cut this right here, a little more than 1 inch or so wide. About 1 inch is fine. Shouldn't be need to have any more than 1 inch, because your resin is going to fill up the seam inside there anyway. All right, so let's take this, and once you've got your aperture where you want it to, you're going to take it and you're going to lay this right over the top of the seam inside your turbine tube. All right, so there it is right there. You're laying right over the top of that seam inside. And let's see if I can get that right there. You're laying right over the top of the seam. And then, let me adjust that just a little bit so that there we go. Maybe just a little bit more. There we go. Okay, so now we're going to lay some resin in there. So, of course, I'm going to need to go back, grab another mixing cup, grab some gloves here real quick. Yeah, there's a couple things you can do to make this seam. One, if you want to measure your aperture, say your aperture is 3 1/4, okay, you get it out to 3 1/4, you clamp it in place. Hopefully you've made your piece big enough when you laid it out. If you need to go 3.5 inches or so, you're going to need to make the width on that somewhere about 10 inches minimum in order to make that 3.5 inch, so you're going all the way around the ABS. Okay, so let's get some resin in here. Should only need 1 pump to do this of each. 4 parts resin, 1 part hardener, and let's grab an acid brush. Now the fun part is going to be getting the resin in there. Now you can put an extender on this acid brush a couple of different ways. You can, I don't know, if you've got some wooden dowel laying around, you can use that. If you've got some brass tubing laying around, we as scale boaters, or we as RC boaters, period, should have lots of brass tubing laying around. All right, so we've got our resin. Now you're simply going to wet this. You're going to wet this fiberglass tape on the inside, and it's going to take a little bit to push that through, and you'll know that you've gone all the way through as soon as that white fiberglass cloth turns completely dark. Basically, it'll be almost transparent, and the carbon fiber will, at least the color of it anyway, and even some of the pattern may even show through at some point. Now, whether you've CA'd that seam, just tack that seam together with some CA, or whether you've actually held it in place with some blue painter's tape, either way, you're going to need to put some blue painter's tape underneath it, because that way you're going to trap in any resin that comes through that cloth, and that's going to fill any gaps you have in your seam underneath. Hopefully you don't have too many gaps in there, but if you do, this will easily fill those gaps. Okay, see how it's starting to turn dark? You're seeing less and less white. And then you're simply going to keep wetting that out with the acid brush until you've got enough resin in there, and just kind of brush it through. There you go. And what's cool is you can even reposition this a little bit if you need to. Before it gets completely cured, you can reposition that a little bit while it's still wet. Yeah, like I say, you're going to need to reach in there. So make yourself an extender with either some wooden dowel. Yes, go ahead. You're going to need to make yourself an extender with some wooden dowel or brass tubing. Or if you don't have any of that handy laying around in the right size, shoot, you can even use a pair of big old pliers. I think I had. Yeah, you can even grab the end of your brush with a pair of pliers and reach in there with that. Even that'll work. So okay, so you're going to continue to wet out all of that resin, or wet out all of that cloth with your resin. Get the one end started so that that's kind of locked in place, and then you can come back and do your other end. And then once you've got both ends kind of firm, then go ahead and start working on the middle and getting that. I need to reposition that just a tad. I just oopsed and moved it over a little too far. There we go. We'll get it right back over the seam. So you can reposition it there, and then you'll go back and, like I say, make sure you got some tape underneath that to take care of that seam. So as it's curing, your resin will fill any gaps in that seam. I actually need a little more tape under the end of this right here. I forgot to get this taped completely. So that's how you're going to do that. I got a little bit of working time left here, so what I'm going to do is I'm going to finish this up, at least to this point anyway. I'll grab a piece of tape. I'm going to set this aside here for just a second. I'm going to grab some tape and take care of that one end right there. So I kind of missed a little bit right there, but that's okay. You still got plenty of working time to fix it if you screw something up like that. We'll just grab some of this tape. All we need to do is just close up that seam right there is all we need to do. There we go. Okay. And once you've wetted that all the way out and your seam is completely filled, that's what your seam's going to look like. This is one where the seam was butted up. I butted up rather than did the overlap. Okay? So, and there you have a turbine tube. This was the one that I pulled off of the cardboard over here. This one is the one that's going on my boat. Now remember how I mentioned earlier how light these things are? I put this on a scale earlier. This comes out at 2.85 ounces. And this is actually going to get lighter because you're going to cut a little bit off of this. This whole length isn't going to be needed to go on the boat. You'll probably end up, or I will, we'll probably end up cutting off probably about 2 or 3 inches of this at least. So once we've completed that, oh, by the way, remember earlier in the video I was mentioning about how when I got my first scale boat, the guy sent me a piece of aluminum. Ironically enough, I was actually rummaging around in my garage. There's that piece that I got sent 15, almost 16 years ago. How heavy that is. Imagine putting that on your boat. So there it is right there. And you know, if there is a little bit of flex to these too. I mean, like I say, with one layer of carbon fiber, there is a little bit of flex to these things. So if you don't want it quite to flex that much, just simply do 2 layers of carbon fiber when you're wetting it out between your layers of Mylar. Okay. So there it is right there. And then in the next video, we will actually show you where is my chrome silver. We'll actually show you. Yeah, whoop, that's not the silver, that's the gold. We'll actually show you how we're going to cover these turbine tubes with this. So there it is right there. In the next video, we're not going to cover these now because if we cover them now, then we're going to be drilling through the vinyl, and we'd rather just do all of our drilling and all of our fitting, and then we'll come back later and cover it in vinyl. It's a lot easier that way. We'll show you how to make the rear aft deck and a nice custom molded cradle to go around your newly formed turbine tube. So once you got it cured, you take all your tape off and you got something like this. Then you can start fitting it to your boat. You know, if you need to have a little bit of a slant at the back of it, you can do. All right, so there you have it. That is part 1 of fabricating a turbine tube. In part 2, we are going to cover a couple of things. One, we are actually going to cover how we're going to finish this thing out. We're also going to cover how to make a rear aft deck for your boat that is custom molded to your newly constructed turbine tube. All righty. So, and by the way, just to show you what we're going to cover this thing in, little piece of chrome vinyl. You can actually pick this up at auto parts store. You can buy it as rocker panel tape, or you can go by a graphic shop like mine and say, hey, got any silver vinyl around? And simply cover it over. We'll even make some tie-down straps to make it look more realistic like the real boat. All right, so there it is. Part 1 is in the bag. I hope you learned something on this. For you guys that have got some advanced skills in fiberglass, hope I didn't bore you to death. But for those of you that have never done much fiberglassing before, hope you learned something. Hope you find something I missed and maybe expand on that, because there's always room. Hey, we're scale boaters. If you stop learning, you're pretty much done. You might as well pack it in, because we're always learning in this sport. So if you have any questions, feel free to email me. You can email me at mike.mcknight@prolinemedia.net, or you can call me at 209-327-2842. So part 1 of Scale Thunderbolt Construction Fabricating Turbine Tubes is in the bag. Look forward to part 2 coming very soon. Thanks again for watching.